First of all, I want to thank you all for joining us today. It's proved to be a really popular topic, which I think is a reflection on the upcoming interest and focus on natural ventilation and particularly automation in the industry. So thanks to all of you for joining us. Just a little bit of background information. So the session is due to run for 45 minutes and at the end we'll have a Q&A session. In your dialog box on the right there, you should have the opportunity to ask questions or drop some text in the chat box. We'll probably save the questions to the end just so that we can try and deal with those all together. And just to introduce myself, my name is Tom Lim and I'm the Sales Director for WindowMaster Control Systems in the UK. So work closely with the team here looking after our customers both here in the UK and in Ireland too. We've got a great team with some really good experience within the industry, and we're here should you ever need us. So without further ado, the agenda for this webinar. Initially, we're going to take a quick look at why we're seeing more window automation in the industry, the different actuator types that are available, easy ways of finding the right products for your applications. We'll take a look at how actuators are installed. We'll have a look at cabling and the wider system, and then some other considerations as well, technical information. And we'll finish with a quick look at WindowMaster and the Q&A session at the end. So without further ado, I think a lot of these themes here will be familiar to many of you, but certainly there's some long-running discussions around in the industry around new building design and existing building renovation in terms of sustainability, carbon reduction, and obviously the more recent push towards net zero. And then there's some emerging themes which are taking sort of getting a lot of airtime as well in terms of wellness and productivity, and then more recently pandemic resilience and how we can ventilate buildings to address the challenges around COVID. Also more discussions around digital technology, smart buildings and intelligent facades, and of course Internet of Things, big data and AI and all of that exciting stuff, which are really pushing natural ventilation and particularly automation to the fore in a lot of the discussions we're having around building design and renovation. When we look at the landscape that we're working in, natural ventilation is featuring in a lot of the design guides as well. So it's featured in the building regulations and the building bulletins for the schools, and that we lean on for university design. Also in the CIBSE and REBA design guides, it features heavily in terms of points and qualification in BREEAM, LEED and WELL assessments. And then more recently, natural ventilation has got a good mention in the REBA and CIBSE and government response to COVID. And all of those documents encourage and recognise the benefits of natural ventilation. A study by the Carbon Trust a few years ago assessed a number of different buildings and looked at the energy savings, which was somewhere between 24 and 70% compared with normal benchmark standards. And on average, those buildings saved around £30,000 a year in terms of energy usage. And those are pretty significant numbers, and that's part of the driver why we're seeing more and more natural ventilation and particularly automation. The World Green Building Council on a recent webinar talked about the basic principles of working towards zero carbon. And they outlined that in essence, we need the design buildings for them to be well sealed and insulated, but also use low energy approaches to control ventilation. And then for anything else that does need to use energy, we obviously use renewables for that so that we can offset the carbon associated with it. And there's some big headlines recently. CIBSE Journal, amongst others, produced some really good pieces where some thought leaders in the industry made comments around how they see natural ventilation going forward. And this is as recent as August and June this year, where we've got emeritus professors of architecture talking about the future of buildings will need to be naturally ventilated for much of the year as possible. The likes of Edmund at Chapman BDSP talking about the general trend towards more naturally ventilated spaces, which has been accelerated by COVID. And you know, Borough Happold, Foster and Partners, there's some big names here who all recognise increasing consideration of natural ventilation in many buildings, and that can also work with mixed mode solutions as well. More recently, of course, we're all addressing the challenges around COVID, and there's a number of documents which have helped give us some guidance on that. The government website and some research that they're promoting talks about using CO2 sensors to monitor air quality in spaces. Of course, any ventilation strategy in a building around COVID needs to be part of a holistic strategy and consider all of the risks and other measures like social distancing. But there's certainly a great deal of mention around monitoring air quality in spaces, ensuring that there's good levels of ventilation, automating that ventilation, and using natural ventilation to purge the spaces and work in conjunction with mechanical systems as well. And people like the International Wellbeing Institute, you know, they're referencing through their studies people like Florence Nightingale, who many years ago was encouraging the use of natural ventilation in terms of reducing transmission of viruses, and that continues to be a theme today, with the World Health Organization encouraging the use of natural ventilation, and REVA guidance too. So why would we want to automate that natural ventilation? I mean, put simply, by automating the windows, we're able to enable the building to be more reactive to the demand for ventilation, to react to weather conditions, and be much more proactive as well in terms of preventing overheating issues and poor air quality. And if we use the right technology, then we're able to deliver very fine control of that ventilation and deliver strategies like night cooling and controlled drafts, minimize heat loss in winter, and we can introduce that energy almost silently now with some of the new technology available, and it complements very well other systems within the building, such as solar shading, mechanical ventilation, and cooling and the likes. So where is it being used? I think probably a lot more than many of us would appreciate. Most of the buildings that we're in have got some form of automation. It's everywhere. It literally is all around us. It's a very, very well established technology, and it works very well when it's properly employed. It works across all sectors, from education, shopping centres, through to sports facilities, hospitals, and offices. And we've got a good deal of experience across those sectors with different projects we've been involved with. And there's some big names there as well. We've done a lot of work with some of the big universities. There's some really prestigious schemes there. But we also do a lot of automation in the smaller sort of primary schools, libraries, and local hubs as well. So it's a very well established technology, and there's some good experience there, and we're delivering some really good results as well. So given the popularity of natural ventilation and automation, I just wanted to give you a very quick introduction then to actuators, and there's a whole range available, all shapes and sizes for different applications, from small chain drive actuators for facade and comfort applications, to the larger chain drives for heavier windows, and particularly for smoke ventilation as well, with longer strokes for bigger free areas. And then of course we have spindle drives still, although most of those now being replaced with chain drives with much greater load capacities, and we also have door drives and locking motors. Just to give you an idea of how broad that range is, we'll take a look at a few slides now, which is just a snapshot of our range. But when we look at them, the key features that will help us to decide which of those products is the right for our applications would typically be whether it's surface mounted or concealed, potentially the colour of it, perhaps less so from a technical perspective at this stage, the chain stroke and the opening capabilities of it, of course the forces that the actuator is able to deal with in both the push and the pull directions. Locking force is really important, of course, for security, and then the size of it, whether it will fit on the window. The majority of actuators that we have are 24-volt DC motors. They tend to be much more friendly for integration into the buildings en masse, and we can do much smarter levels of control with these. They're easier to integrate into buildings and operate on a frequent basis. And you'll see at the bottom there that almost all of our actuators are motor-link enabled, and we'll touch on that later on. But you can see a whole range of actuators, some more compact actuators with strokes up to sort of 500 millimeters, and then as you get to the longer strokes of 600, 800, and 1,000 millimeter strokes, obviously the size of the actuators increases accordingly. And we've got actuators with force capabilities up to 1,000 newtons or more, according to the application. We've also got drives for louvers and for operating espagnolet locking systems, as well as door actuators. So you can see there's quite a big range there. And of course, when it comes to product selection, that means there's quite a lot to go at, and there's a lot of different considerations, and that can seem fairly complex. Typically, actuators are normally selected based on the orientation of the vent, how big the vent is, how far it needs to open, the amount of glass in it, or the weight of the vent, so that we can calculate the load on the actuator, and then whether it's for smoke or comfort ventilation. And that's a lot of information to try and assess, and some fairly complex calculations there. But we've found, we've developed a solution which makes it really easy to help you to find the right actuator. So our actuator finder tool, some of you may have seen it, is available on our website, and it makes the process really easy and gives you some really useful information as well. So just a few simple steps will help you get free area calculations and take a look at the actuators that are the right ones for your application. So go to our homepage and you'll find there our actuator finder. Click on the actuator finder. We find a lot of people are adding it to the favorites bar because it's a really useful go-to tool. And all you need to do from this point is enter the basic window information. So whether it's a facade window or roof light, the orientation of the window, whether that be outward or inward, top, side, or bottom hung. Then you can enter the dimensions of the window, and either the glass thickness, which is probably the easiest way of doing it, or the casement weight if it's something more challenging or perhaps doesn't have glass in it, but you do know the weight. And then you can select the method of ventilation area. Typically in the UK, we go with the rectangle at the throat of the window rather than using the triangles at the sides, but it depends sometimes on the project. If it's comfort ventilation, sometimes we'd include the triangles. Then you can go to the advanced settings, choose the basis on which you want to select the actuator. So that could be based on the stroke, or it could be the free area that you're looking to achieve. And then all you need to do is click Find Actuator, and it will give you a suggested actuator solution and some of the important information that comes with that around your selection. So the forces on the actuator and the opening angle that can be achieved, as well as the geometric free area. If you click on the Save Information PDF, then it gives you a really useful PDF output of that selection. It summarizes the actuator that you've got, the stroke of it, the geometric free area, and then it's got live links then toward the technical drawings, data sheets, installation instructions, and specifications as well. So it's a really nice, user-friendly process, very quick way of getting to an actuator selection. And within that PDF, you've also got a link at the bottom as well. So it summarizes the information that you use for that selection that gave you the output, but also gives you a link so you can always click on it, keep it within your project folder, and when you need to return to it, click on the link and it'll take you straight back to the point where you arrived at that selection. So really nice, user-friendly tool. If you get stuck or you want some further guidance on it, you can always click on the contact button on there as well, and one of our guys will get in touch and help you out. So product selections are easier now than they've ever been, and the sort of information that we can get out of tools like the actuator finder make day-to-day consideration of free areas and actuators a lot easier to handle. So for those of you in the room that are geek like me, you might be interested to know what's inside and how an actuator works. So typically, of course, you've got the housing on the outside. That will vary in size depending on how much gubbins we need to get inside, typically dictated by the length of the chain and the forces and how big that chain needs to be. The housing is normally painted, powder coated or anodized, according to the different type and the project preferences. We'll have the chain and the chain cartridge. We'll have a motor, and of course, the bigger the load, the bigger the motor, and the higher the amp draw. Let's say most of our actuators are 24-volt DC, although we do have some mains options as well. And there'll also be some electronics within that motor as well. In more basic motors in the market, they will simply be a protective device to prevent the motor from burning out at the full extent of the stroke, whether that's fully closed or fully open. But the newer generation motors like those from WindowMaster offer some really good, useful functionality to help address some of the common challenges and improve the performance of the windows and the automation. And particularly for smart buildings, that intelligence and those extra functions are really important. So what we call MotorLink can help enhance the performance of the building. It can help deliver far better levels of control and do it much more quietly than traditional actuators that have been in the market that don't have this technology. So just to give you a quick insight into MotorLink, I suppose the biggest difference between MotorLink actuators and other standard actuators are, rather than just powering windows open and closed, MotorLink gives the opportunity to talk to the windows. So we use network-based controllers, which allow the control system then to talk to the actuators. It's very, very accurate. They can send windows to a specific percentage position, and they can also get feedback from those actuators as well. For example, if they've been overridden, or to know that the windows are closed at the end of the day for security purposes. And we can also do that in an automated mode, which is very slow and quiet, or we can do it much more quickly when we need to react to functions like rain or for smoke applications. So MotorLink, really key sort of technology for smart buildings and for those that are looking for a high level of performance and control. But we can also use our actuators in a very basic 24-volt operating mode if we need to. And sometimes that's right for simple applications like operating roof lights, or for high-level windows which are just operating off a switch on the wall. Let's take a quick look now at fitting window actuators. So our data sheets and our installation guides are a really good go-to resource in terms of working out actuator fitting. And as we saw, we've got links to those within the actuator finder and the actuator finder output. And they offer a good kind of typical mounting example for most orientations of windows and different profiles. And of course, we've got our guys in-house that can also help on specific applications should you need it. For smoke applications, it's important, it's much more rigid in terms of the way that actuators are mounted. They need to follow the tested arrangements and use the components that have been approved as part of the testing and technical documentation, which is followed as part of the factory production control of those smoke vents. So you can see different orientations of windows there, and we'll take a quick look at the different sort of typical mounting arrangements. DWG drawings are also available on our website and from each of our product pages, and again from the actuator finder output. And the final mounting arrangement does depend obviously on the profile, the window orientation, and the different brackets used. All of the installations typically will use riv nuts and normally Loctite, where we've got threaded components, so we've got a good, robust, long-term and secure installation. In terms of positioning the actuators on a vent, when there's only one actuator being used, and on an aluminium profile, that's typically up to around 1200 wide. That's dictated by frame flex. So when we have a single pull point to close and seal the window, it's similar to a cockspur handle, and each of the different profile manufacturers will have some guidance that they would give you as to when you might need to go to more than one locking point, or multiple actuators or handles, or indeed on some of the bigger windows, we may need to look at locking motors to drive Espagnolet locking systems, or it may be a case that it's acceptable to use more than one actuator. So if it's a single actuator, typically the chain would be mounted on the sash in the center of the window, and at equal spacing, quarter spaces for a pair of actuators, and so on. And there's some good guidance within our installation manuals for that. If, of course, there's more than one actuator, it's really important that those actuators are synchronized on the window so they don't skew the sash, and our actuator technology enables that very simply through the cabling arrangement. A quick example of a top hung mounted window, probably the most common arrangement in the UK. It's good for actuator positioning. There's some good flexibility there. We can normally achieve good opening distances and free areas, and it's pretty resilient to our UK weather. And the fitting principles, I guess, are the same across all systems. So it's a case of planning, downloading drawings and the installation guides, getting a good handle of what's needed, finding and marking the correct mounting locations, double checking, of course, those positions with the actuator or a template, drilling the holes, fitting the riv nuts, brackets and the motors, and then testing and commissioning the actuators that can often be done by from a 24-volt DC power supply. Our actuators, because they have to fit different windows with different distances in the closed position, you go through a short commissioning process of opening and closing the actuator, and that helps it to find its home position and sets that at the initial commissioning. Butt hinges versus projecting hinges. I wanted to spend a short amount of time just considering this, because the applications have got some subtle differences which is good to understand. So with butt hinges, the loads on the actuators are much more easy to calculate. The forces required on the actuator tend to be a bit higher, but we know what they are, and that's the basis on which our actuator finder works. We can normally achieve good degrees of opening with butt hinges, and on shorter stroke applications, the actuators may be fixed in their position, and the chains are designed to allow the chain to bend with the arc of the window opening. And on longer stroke applications, we may use an actuator with a longer chain and with a pivot bracket, which allows the actuator to pivot and tilt as the window opens. With projecting hinges, it's important that the friction stays are set to no friction and completely released. Normally the loads on the actuators in the opening stroke are lower, and the path of the chain is obviously different. It doesn't arc upwards. It normally drops or is more horizontal chain path, and depending on how far you're trying to open those windows, it's important to consider the path of that chain if it does drop, to make sure there's no conflict with the profile. And it's also important to understand that if you are looking to achieve high degrees of opening with projecting hinges, the forces required to overcome the hinge geometry in the fully open position can be quite high, and it's something that needs careful consideration. We can offer specialist guidance on that, and sometimes we would recommend that a mock-up is built to test the solution. The majority of the time, it's possible to calculate and estimate what the best arrangement is without a test. Side-hung windows follow very similar principles. Our actuators are normally mounted with the cable exit at the top, and that helps for the best chain rigidity in that arrangement. With side-hung windows, it's also important just to consider risk of entrapment and drafts as well, particularly with tall windows where people might be sat next to them that are opening in winter. But advanced functionality like MotorLink can help address that through very accurate trickle ventilation, and we've also got some enhanced functions like pressure safety function that we can take a look at as well as part of the overall design, health and safety assessment of that arrangement of windows. Parallel opening vents have become a bit of a new trend, I think, in recent years. They normally feature 2 or 4 fully synchronized actuators, depending on the size of the window. The majority of the weight of the vent is held on the hinges, and so the actuators are there literally to control that and overcome the friction of the hinges. Quite often cover profiles might be used to conceal the actuators and the cabling. Quite a nice example of a large project. It's a Schuko project we were involved with a few years ago with nearly 7,000 actuators on it, controlling a good number of parallel opening vents. So parallel opening vents, yeah, we can also automate those. Inward opening windows, I've seen quite a few of these on projects in recent years. Yes, it's possible to automate them. I think there's some extra sort of considerations for inward opening windows. There's two ways of mounting the actuators. If there's headspace there, we can fit them on the frame, but normally you'd have a Z bracket there, so you need to just ensure that that's acceptable to the client. Or if there's not sufficient headspace, it may be possible to mount the actuators on the sash. But in that arrangement, you need to just give a bit of extra consideration to the cable routes around the outside of the sash to get it back onto the frame. Another thing to mention with inward opening windows is that there is a natural path for the chain to make, and so it's possible that there would be a more restricted opening with an inward opening vent as opposed to an outward opening vent. So you can see there in that diagram on the right that with a higher degree of opening, the chain is trying to cut across the profile as the angle of the window increases. So it's another thing that just needs a bit of consideration. So for big openings, big opening areas, typically outward opening vents offer more flexibility in terms of mounting arrangement and chain path. Concealing actuators and cabling. There's certainly an appetite for hiding actuators on a lot of projects, and there's some really nice solutions that have been around for some time on composite systems like the Velfac arrangement that you can see there. Concealing actuators in aluminium profiles has historically been a bit more challenging, mainly because we want a nice low profile window system, but equally there's not much space to be able to fit an actuator into it. That has changed more recently with newer actuators that have come onto the market that we've launched more recently. And with concealed actuators, I think it's important just to consider things like the risk of cable damage and also how you access those motors going forward for maintenance should it be required. So concealed actuators, really nice when the solution is well proven and developed, and that's something that we're happy to work with you on, but there's also some extra technicalities that need a little bit of thought as well and a bit of planning. With our newer actuators, WMX813 and 814, they are super low profile and they give more flexibility than ever to look at concealed arrangements within specific window profiles, and that's something we'd be really happy to consider with you. The other option to concealing actuators is using cover caps. And actually, quite often, this is a really nice, cost-effective solution. So you can see the picture on the left there, that's a pair of actuators mounted on the window. They've not been color matched, and that's because they've got this really nice, neat L-shaped cover cap, which fits over the actuators. It helps to conceal the actuators, but also the cabling, and it means that should you ever need to access those actuators or cabling for maintenance, you clip off the profile, you can do the work that you need to do, and then you pop it back on. And it's often a really nice, neat, cost-effective solution. And there's also less chance of cable damage pulling cables through frames and during window installation. And there's any number of different types of cover profile arrangements that we've seen in the past, and there's some drawings there just to give you an idea. Some of them that are just using color matched capping profiles, pressure plates, or that are sit on brackets as part of the window arrangement. Again, it's something that we're happy to explore according to project requirements. So what about that cable? I think in the past, we've seen a lot of actuators fit to windows by one party, and then somebody else comes along much later in the day, and we've got a coil of cable left on the actuator, and there's a lot of head scratching goes on as to how we get that cable from A to B. And I think it's really good practice that we consider early on, where has that actuator cable got to get to? Actuators typically come with between of actuator flex pre-fitted. So we just need to work out, does that flex need to go up or down, left or right? Are we going for surface mounted arrangement, or are we looking to go through the profile? And where's the exit points, and where is that cable actually going to go onto from that exit point from the window system? So once you know the route of the cable, then you can start to plan how you get it from A to B. Quite often, surface mounted trunking or colour match capping is acceptable if you've got curtain walling system, or if your frame section allows, then grommeted holes and draw wires may be a possibility. You can see on the diagram on the right there, it's really important to consider protecting the flex. Silicon flexes, which are typically used with actuators, are highly pliable, which is good in one sense, but they're also relatively easy to damage if there's some nasty burrs there that you're trying to pull against. So again, a little bit of caution needs to be used by protecting those actuators and the flex as far as possible. And then in terms of containment for the cables on the windows, depending on the line of sight, so for higher level windows, so I've just got a message to say we get some interference here on, just turn this off. So for high level windows, where you can't actually see the flex, quite often it's acceptable to have clips that fix the cable in place but don't necessarily obscure it. Whereas if you've got cable that's in line of sight, you might want to consider either hiding that cable or using surface mounted matching containment. And then we'll just take a quick look at the basics of wiring and the wider system. So typically the actuator cable will be taken back to a local connection point or junction box, and from there there's field wiring, motor line that we call it, that will go back to the control unit, and that normally is a 3-core flexed, sized to suit the application. Then you would have your control unit, which has got a mains input. Sometimes you have a rain sensor input or weather station, a wall switch to operate the window, and perhaps a remote control. Some of our smaller units have got really nice remote control functionality and Bluetooth. And that's a fairly sort of simple arrangement of the wiring in a simple system. As we start to get onto larger systems, which have got more than one group of windows that need to be controlled, there'll be multiple motor lines. And perhaps if you've got a group of windows that you want to control together, then you can have a number of actuators wired back into a local junction box, and then a single flex back for that motor line back to the controller. And those windows would then be operated as a single group of actuators. Where you've got windows with more than one actuator on the vent, as we mentioned earlier, it's important that they are synchronized, and therefore they have to have their own motor line. So each window with multiple actuators would have its own motor line, and by connecting the green comms core within the actuators, that allows the actuators to find each other and make sure that they operate synchronously. And we've got a whole range of different controls, from small compact controllers suitable for 1 or 2 actuators, up to larger control panels. For our smoke panels, they can go up to 60 amps, but for our comfort panels, typically a 20 amp controller will operate up to 21 amp actuators, and we can have up to 10 motor lines from that controller, all with independent switch inputs, and you can have a global weather station or rain sensor input. And our MotorLink controllers are network enabled, so they can be easily integrated into the BMS via PACnet, Modbus or KNX. And again, we can happily give a design support on those solutions. And in the bigger sort of smart buildings that we look at, the overall system can be much more sophisticated. The controllers sit on controls network, and then you would have some sort of system panel or head end or brain that would be monitoring each of the zones using sensors in the spaces, and optimizing the different groups of window positions according to ventilation demand in those spaces and weather conditions. There's lots of other technical information available. Our data sheets and installation guides are a really good starting point, and they will outline things like minimum window sizes and the bend radius of chains according to the orientation of them. And we've got a whole host of different bracket arrangements as well for different window profiles. And the data sheets also set out the force capabilities of each of the motors as well. And if there's a specific force curve for those actuators, that will be detailed too. What about special colors? Oh, we get asked this one a lot. Yes, ultimately, unlike the Ford Model T, you can have almost any color that you like, but there is a cautionary note to add with that. There is a cost in our factory. We've got standard production lines producing each of our motors. So if we have to stop that production line and flush through the paint lines and obtain a nice hot pink color to add to your actuators, and then we spray your actuators or powder coat them accordingly, clean the lines through, and then we have to go back to our standard production. Of course, there is a fixed cost, the changeover cost to that. So if it's a single motor that you're looking for, then the cost for that motor can be high proportionally. But if you're looking at a larger scheme with 50, 100 motors or more, then quite often we do produce special motor colors with no issues at all, and your building can indeed look fabulous after all. Sometimes on the bigger schemes, it's a good idea to consider contingency spares as well, should they be required in the future, because color matching single replacements in years to come can be a costly exercise. So quite often that's done up front. And of course, when you're looking at color matching actuators, concealing them behind a cover profile is often a very cost-effective alternative. What about smoke applications, I hear you ask? Smoke applications are slightly more complex, and the free areas certainly need a little bit more consideration according to specific guidance and the regulations, and the actuators used need to be installed under an audited factory production control process, using only the actuators and components with systems that have been joint tested together following the prescribed fitting methods and arrangements. We've got a really handy guide that helps to make that process a little bit easier to understand, that you can download from our website, and we've got specialists in-house that can help you, guide you through that process of getting set up with an FPC to allow you to build and CE mark smoke vents. So please do get in touch if that's something that you would like to discuss with us. And window automation, window actuators, it straddles disciplines really. It's part of the architectural package, it's on the windows, it's part of the main builder's package, it's with the window fabricator or the facade specialist, but equally there's electrical cabling there, it's part of the M&E design package and M&E subcontract package, and potentially the BMS as well. So with so many different parties involved, it's really important that we get good coordination to make sure that everything connects just as we expect, and there's no hidden gaps or extra costs or issues later on once on site. So we really encourage, if you're involved with a project with automation, give one of our guys a quick call. They're really happy to give a bit of a steer and support to the different parties involved, and make sure that the outcome is one that's best for everybody, with as few callbacks as possible and as happy a clients as we can possibly get. And just finishing up then, so for those of you who haven't perhaps dealt with WindowMaster, we've been around for a while. We're over 30 years in the market now with industry-leading actuator technology. Our headquarters is in Denmark, with our manufacturing in Germany, and we've got sales offices in 6 countries. We've produced over 1.5 million actuators that we're proud to be out there making buildings operate more comfortably and more energy efficiently. And we service customers in more than 20 countries through a network of certified partners and key accounts. So we're here to help. We've got a great deal of knowledge, great team, really friendly, knowledgeable bunch of guys who we're very pleased to speak to you and see how we can help with your project. We've got experience from thousands of projects that we can bring to the table. And quite often that means that the outcome that you get is a better one, and often more cost effective too. So at this point, I would like to invite you to connect with us. We have got a WindowMaster page on LinkedIn, which can keep you up to date with the latest industry news, new products, and keep you and your colleagues informed of new webinars like this one. Hopefully it's been useful. You find my details there as well. You're very welcome to email either our centrally email account or my email there, should you wish to follow up on this webinar. And all that leaves is for me to thank you for your time, and the chat box, the question page is now open, and I will do my best with my colleagues here to answer any questions that you might have. I'm sure we'll make this webinar available on our website, and please, if you found it useful or you think your colleagues might, please send them to our website or get them to get in touch, and we'll do our best to help them too.
So Tom, we have a question.
Yes.
So are actuators suitable for residential, and is there an option to control the actuators from a smartphone app or link it to Google Assistant?
Ooh, good question. So our latest, are they suitable for residential? Absolutely, yeah, widely used in residential applications, particularly, well, historically it was where there was accessibility issues, high-level windows, roof lights, extensive automation for roof lights. And new controllers have got remote control capabilities and Bluetooth capabilities. They've come onto the market this year, proving really interesting. The Bluetooth technology means that we have got much more scope then to develop other applications, but they can also be integrated into other home automation systems as well. So yes, there is almost certainly a solution for that.
The only other question, Tom, is that could we get the slides via email afterwards, which I'm sure we're happy to do, aren't we?
Yeah, absolutely.
Yeah.
I think we'll send a follow-up email. You're welcome to contact us if you'd specifically like a copy of the presentation, and I'm sure we'll share the presentation on our website as well if you did want to share it with colleagues. Any other questions? That was easy.
There is another one. Does the free air calculator take into account frame depth?
Yeah, so in the advanced settings of the actuator finder, it gives you the opportunity. It uses a ready reckoner so that we can get quick results for most sort of design outline information. But it does give you the opportunity to put specific frame dimensions in there. I think it's worth adding that if you've got smoke applications, then the method of calculating the free area and the specifics of that window need considering more carefully, whether that's to achieve approved document B or aerodynamic free area calculations. And the actuator finder tool is without doubt, it's a massive step forward to make that process a lot easier. But if you've got specific free areas that need to be achieved, particularly for smoke, it's worth giving us a shout. Any other questions for me?
Yeah, there's a really nice question here from Ted about service and maintenance. And he is asking what will most likely need to be serviced and what parts are serviceable?
I think in certainly in larger projects, it's a case of monitoring the actuators for fault, which is something that our MotorLink technology can do. And of course, those faults can be caused by damage to cabling or to the actuators themselves, more often than not. But long term, the maintenance regimes are relatively simple. Inspections and checks on the health of the windows as part of that, and making sure the actuators operate correctly. And sometimes it's a case of addressing preemptive maintenance like that, like greasing hinges, making sure that they're clean and the windows operate freely. The operating lifetime of actuators is actually very good. We're sort of looking at typically 15 years, I guess. And we've certainly got actuators that have been out there a lot longer than that, if they're properly looked after, if they're not knocked about, and the windows are looked after and they operate the way that they should do.
Awesome. Thanks, Tom. You also have another really great question here. Do you have a fire-rated product that can be linked to the fire alarm systems?
Yeah, we've got a whole range of different actuators which are designed not just for comfort ventilation, but smoke ventilation, or specifically for smoke ventilation, and smoke panels which have got battery backup. All of our products that are used for smoke are fully tested to the relevant standards. So for our smoke panels, it's the N12101 Part 10. And for our actuators with the tested solutions that we have, it's the N12101 Part 2. And providing they're built in the correct manner by the appropriate manufacturers, then they're fully certified too. Any more for me?
Yeah, there's lots more. Really great one here.
Okay,
Another one
good.
with regards to CE marking from Mike. What routes to CE marking of smoke vents do you offer? Fitted by window fabricator, fitted by your operatives in a window fabricator's factory, fitted on site, etc.?
Yep, good question. Really good question. And I think this is one of the sort of hot topics in the industry at the moment, with more and more focus on smoke ventilation. The FPC guide that we've got on our website gives a really good insight into that, and we've got a team of specialists. There are a number of different routes to delivering on that FPC, but our focus really is working in partnership with fabricators and manufacturers to bring the FPC process in the factory to control the manufacture of the vents and the design and coordination for the actuators as per the tested solutions that we have, and ensure that what you end up with on site is controlled in the delivery process and certified accordingly with the relevant declaration of performance.
Okay, Tom, you've got more. So do actuators require, or is it recommended to lubricate? Unfortunately, I don't know, Laura, if you can expand, but it's kind of cut the question off for me. Oh, sorry. Are you recommended to lubricate moving components?
I think, now you're testing me now. I think typically not. Normally the actuators are kind of lifetime greased from my understanding, and there's possibility that one of the guys from our service department will correct me on this, but I believe I'm correct in saying that they're lifetime greased. They wouldn't normally need relubricating unless the chains got dirty and they needed cleaning. So I would say typically not, but they do benefit from an inspection, as I say, a check of the window operation to make sure that everything's operating as it should do.
Okay, I've got another one. Should roof lights / windows that are comfort venting close on fire alarm?
Typically, that would be set out in the fire strategy for the building, but I would suggest normally yes.
Can you elaborate on getting the cabling through aluminium profile?
I could do, but I would be speculating to a degree because every profile is different, and the way that the windows are assembled, whether it's curtain walling or window inserts. But we see it on a lot of projects. It's certainly something that is desirable during the design stages. The delivery of it certainly needs a lot of coordination. I think that the most important thing is to understand the potential for damaging the cables. So what you can do is fit an actuator, pull cables, fit an actuator and test it, and it works perfectly well. But then in the process of fitting windows and pulling cables through, you potentially end up where you come to commission the system and you've got operating problems. Normally that's because it's not, the cable's not been protected as well as it should have been. So grommets, making sure that the wireways are clear, and draw wires. Quite often, if we are trying to conceal cables in window sections, it's preferable to fit another piece of cable within the window. That can be fully continuity and insulation tested before and after fitting, and if need be, used like a draw wire afterwards should it become damaged, and then we connect into that local to the actuators. There's lots of different ways of doing it, and there's also limitations depending on the specific system.
Okay, another one. Will automated windows become a trend in residential buildings? What's your opinion?
Ooh. I'd like to think so, yes, but I think, you know, there's certainly, with the discussions that we're having on IoT, Internet of Things, smart homes, asking Alexa to make your dinner for you, why not open the windows? And I think in terms of zero carbon and the aspirations to reduce the amount of energy usage, but equally improving health and well-being in buildings, I think we're seeing more widespread automation across the board. So yeah, why not? Why wouldn't it be potentially something that will become more of a focus in the future? We're very lucky in the UK actually that our climate lends itself very well to use natural ventilation much of the time. You know, we have a really good climate that works well with natural ventilation, and will do for many years to come.
Yeah, we also have another really nice question here from Simon about the actuator finder. Two questions. The geometric free area quoted in the Ready Reckoner, is that the alternative method of measurement in ADB or EN 13141-1?
So the method that we used is based on ADB. So it uses the rectangle at the throat of the window at right angles to the direction of flow as set out by approved document B.
And then we have another one here as well from Amir, and he asks, can you elaborate on getting the cabling through the allo profile?
Which I think is, yeah, similar possibly to the previous question.
Sorry, the same question. Sorry, yeah, that was a question. Yeah, sorry, Laura, I didn't say who it asked it. We do have hold on, the next question. We've got a fair few, Tom, so we're keeping you busy.
I like questions. Good. I've got a cup of tea here, albeit it's gone cold.
I'm an architect. This is from Amir again. Can you elaborate on the power/control lines that operate the actuators?
Yeah, I mean, again, it's definitely something we're happy to support. It's specific to the project. It depends where the windows are located, how we want to group them together, what the cable runs are, which controller we're using, what the preferred control location is. But essentially, 3-core flex is the go-to for us between the actuator group and the controller, and then the size of that flex needs sizing according to the load on it, so the number of actuators and how big the actuators are, and the wiring run between the actuator and the controller. It can sound really complex. It's actually fairly simple to deal with when you're familiar with it. So best bet, love it if you dropped us a line and we can get one of our guys to help you with that.
We've got another question here, Tom, from Gillian Anderson saying, if comfort windows are required to close on smoke, do they need battery backup in the panel? And do the actuators then need to be smoke rated?
Hi, Gillian. Thanks for the question. It rather depends on the application, where the type of building and the fire strategy for it. You could argue that really it should close on fire to reduce in areas where you want to stop fresh air from feeding the fire. But of course, if you didn't automate those windows, you'd have manual windows and nobody's going to stick around to close those in the event of a fire. If it specifically is part of the fire strategy that non-smoke windows should close in the event of fire, then it's more than feasible to do that, but it's just understanding exactly what the specific project requirements are.
Alan Walsh has asked, do you offer any training or designing compliant systems, both web-based and classroom?
Oh, it'd be nice to get into the classroom again. We haven't done so many face-to-face training sessions recently, although there has been a few. But yeah, training sessions is definitely something that we're happy to look at, and we can run those virtually or face-to-face. We've got a nice little training setup in our office in Kettering, but equally now with more people working from home, sometimes depending on what we're trying to cover, we can do that virtually.
Okay, this is a question from Ted Summers. Are there any specific health and safety regulations to think about, like finger entrapment? And is there anything specified within the documents like sensors or rubber strips, or does the operator have collision control?
Good question. Yes, there are specific EN standards, the number for which escapes me right now, and I really should know that. But as part of the design of automated windows, the location of them, the height of them, the distance of opening should form part of the overall health and safety assessment, including things like risk of fall. So yeah, it's a great question. Yes, it does need to be considered. Normally, it depends on the opening distance of the window and the location of the window. Again, it's something that we can help advise on. We do have extra functionality within our actuators, so we can have pressure safety function, which is set up on specific high-risk applications. For example, if it was a primary school and at a low level, that's definitely something that needs looking at. And we can set up the sensitivity of the actuators to detect objects when it's closing, and that can offer a much more enhanced level of safety and reduce the risks. But the residual risks of that still need to be assessed, particularly at the hinge side of the window, depending on the window location. And then there are then third-party products that can work very nicely with our actuators to help offer even more protection, and that can be things like PIR sensors, laser sensors, bounce strips, as you mentioned. So yes, health and safety does need considering. Depends on the project, depends on the window location, depends on the type of occupants in the building. But again, you know, we can bring our experience and knowledge to the table with that. So drop us a line.
And then Tom, apologies if you've answered this already. It's just a bit difficult to see some of the questions, but we've got a question here from Ted Summers that says, service and maintenance wise, what will most likely need to be serviced and what parts are serviceable?
Excuse me.
Oh yeah, I think we did answer that question.
I think
I did, okay.
Sorry, yeah, I think the maintenance regime is relatively simple, and it's more a case of inspection, making sure everything is operating correctly and that the windows are working without unnecessary levels of friction. Excuse me, what a finish. Any more?
Not that I can see.
No, me neither.
That was great. Well, look, thanks everybody that's that turned out. It's been a really popular webinar, it has to be said, and as I say, we'll make it available online. Please, you know, mention it to colleagues or people that you're dealing with on projects that you think might benefit, and share. And yeah, do connect with us on LinkedIn, and we'll keep you up to date with new information, new products, and new technology as it becomes available. So, thank you very much to everybody that's attended.